Hi, welcome back to this channel. So today in this video I would like to talk about additives for lubricating oils. In the last video I showed you this oil, which is a synthetic lubricating oil for engines. We will discuss about what kind of components are added into this lubricating oil so that this oil can perform very well. So this oil came from this package. So here you can see it is a synthetic, and the grade of this lubricating oil for car engine is SAE 5W30. So this is the grade of this engine oil, and this is fully synthetic. So I will read few things from this package. So it says SAE 5W30 is a fully synthetic premium engine oil manufactured with specially selected synthetic base stocks developed for passenger cars, operated on both gasoline and diesel fuel, and manufactured by various OEMs. It is a fully synthetic type PCMO oil developed with advanced additive technology engineered to meet the latest emission norms required by the new generation petrol and diesel cars. It is a high performance engine oil with excellent wear protection and superior protection against harmful deposits and acids. So we can see that what is important for lubricating oil. It talks about wear performance, harmful deposits and acids. Then it says benefits: optimum performance, enhanced engine life, highly temperature stable, versatile and cost effective, keeps engine operationally efficient, outstanding protection against rust and corrosion, easy start at very cold temperatures, increased fuel economy, outstanding engine cleanliness, excellent wear protection, improved control of oil consumption, superior foaming control. So these are the benefits. So basically all engine oils or any kind of lubricating oils for gears and for transmission equipments, generally these kinds of benefits we are looking for, and that's why we add additives in the oil. So this kind of oils which has the base oil, this is a synthetic, it has synthetic base oil, and the additives. The additives are of various kinds, and that's why this oil is not a normal oil, and it has got better wear protection and also better life in the engine. So we will discuss about these additives. What are those additives that are necessary for the wear performance and for overall wellness of the engine? So as I explained before, lubricating oils for engines and for any application has two components. The first one is the base oil. So the base oil will be either mineral oil or synthetic oil or a mixture of the two. And the second part of the oil will be additives. And there are many additives which needs to be added in order to get the right kind of performance. So here I will explain to you all the important additives. The first one is anti-wear additives. So this type of additives, actually what they will do is they will form a film on the steel surface, and this film or layer will actually protect the steel surface from wearing out. So some of these can be used for low temperature application, and some of them can be used for high temperature applications. Among all these, TCP and ZDDP, these are two very important anti-wear additives, and they are also used for other purposes, but their performance as a additives which can form a protective film on steel surface is very important. ZDDP is actually a phosphate organic metal phosphate, and this molecule has high affinity to steel surface, and under high pressure and temperature actually it can form a very adhering film on the steel surface, which protects the steel surface from wear, as well as it protects against oxidation of the oil, and also it acts as a low friction material. The next is extreme pressure agent or EP agent. So for applications such as in gears where the pressure is extremely high and speed is also high, in that type of condition we need extreme pressure agents which form a very tenacious, very strong film on the metal surface, and it protects the metal surface again against wear and any kind of damage. And these type of agents are mainly sulfurized or phosphosulfurized fatty oil and other kinds of chlorinated paraffin oil and chlorinated paraffin wax. So these kind of materials are used as extreme pressure agents. They can be used in oil, lubricating oil, as well as they can be used in greases. There is one issue with extreme pressure agents. These are all sulfurized or phosphorus containing molecules, and they are very corrosive to some metals. For example, they are corrosive to copper or any kind of non-ferrous materials. The other important additive is oxidation inhibitors. Oil inside engine or any application comes in contact with air and oxygen, and therefore under high pressure and temperature the molecules are prone to get oxidized, and once the molecules get oxidized, basically it loses the lubricating property. So this is the order in which we will see the oxidation resistance. So this is most resistance. Paraffins are most resistance, naphthenes, aromatics, other additives, asphaltenes, and unsaturates. So the unsaturates are least resistant. That means they can oxidize very easily, whereas paraffins are the most resistant. So this is the reason why in oils we prefer to have more paraffin molecules so that the oil can resist oxidation. However, there is one issue. The substances that reduce oxidation resistance tend to improve boundary lubrication. That means these substances which reduce oxidation resistance actually help in boundary lubrication. So as you know, for lubricating oil we also need boundary lubrication property. So therefore we have to see whether we need better oxygen resistant or we try to improve boundary lubrication. The trend is that we have the base oil which is as oxidation resistant as possible, so they are paraffinic, and we get the boundary lubrication by additives. So here are some important antioxidants. So metal organophosphates, again ZDDP, which we talked about before, is a very good antioxidant material. Other than that, there are amines, organic phosphites, and organometallics. So these are the compounds which are added in the oil to improve its oxidation resistance property. Another important aspect is the rust and corrosion inhibitors. The rust inhibitor is basically for protect ferrous material from rusting, and corrosion inhibitors are for protecting other non-ferrous metals. Corrosion inhibitors are metal diethionophosphates and other metal containing organic compounds. They also contain sulfurized and phosphorus in them. The rust inhibitor to protect ferrous material from rusting. So these are the materials that can be added into the oil so that the oil can protect the ferrous surfaces, and in most of the applications we have ferrous like iron and steel, so they are very much important. But again, there are also aluminum or copper in them, so we need corrosion inhibitors as well as rust inhibitors. So oxidation products, presence of water and some additives are most damaging. Corrosion or rust or corrosion happen because of the oxidation products, and oxidation products contain acids. So these kind of acids will attack the metallic surfaces. Then presence of water is also another reason why the rusting and corrosion takes place, and some of the additives are also damaging to the metal surfaces. So these are the additions we can make to protect the metal surfaces. Other type of additives are friction modifiers. Friction has to be reduced for any kind of machine, especially for engines, because high friction means high energy loss. Any molecule that can form a layer between the two rubbing surfaces and reduce friction can be used as a friction modifiers. Traditionally, friction was modified by blending, which is called compounded oils. So for example, vegetable oils were added into the mineral oil, and these kind of mixture of oils used to provide better friction reduction. Mineral base oil is now replaced by polyglycol for low friction. Organic fatty acids and amines, lard oil, high molecular weight organic phosphorus and phosphoric acid esters are also used as friction modifiers. The other additives are for viscosity index improver. Viscosity index is a term which basically shows the sensitivity of viscosity to temperature change, because a machine has to work in both cold temperature as well as high temperature, and because of temperature change the viscosity can change a lot. So some additives are needed so that the viscosity of the lubricating oil does not change much. That means for low temperature it does not become very viscous, and for high temperature it does not become very thin. There is less sensitivity. That means if the lubricating oil has high viscosity index, which means it is less sensitive to temperature change. So long chain molecule polymers help to reduce effect of temperature on the viscosity of lubricants. So these molecules are added, for example, polymethacrylates, polyisobutylene and olefin copolymers. So these kind of polymers are basically they are large long chain molecules. They are added into the lubricating oil to improve the viscosity index. Now the other aspects related to the flow of lubricant is pour point depressant or pour point. The pour point is basically the temperature at which the lubricant can still easily flow out of, let's say, out of a beaker. If temperature is going to go down further, then the lubricant will not flow like a liquid. It is important that pour point is depressed, is lowered as much as possible, so that the oil can be used in a cold environment. The pour point of lubricating oil should be low, in the range of -20 to even -50°C. So these materials are added into the lubricating oil to reduce the pour point, to lower the pour point, so that the oil can be used even at low temperature. Other kinds of additives are detergent and dispersants. So the role of detergent is basically to clean the surfaces of the metallic surfaces, and another role of detergent is to keep the environment alkaline so that it can reduce any acid present in the system. So detergent can help the metal parts from getting rusted or corroded. And the role of dispersant is to disperse any kind of contamination, especially the soot and other products, degraded products. So together they can help to avoid formation of sludge in the lubricant, and also they will avoid formation of any kind of deposits on the metal surface. So this will keep the engine or the metal parts, the machine, very clean. So these materials are used as detergents, metallo-organic compounds of barium, calcium and magnesium, and dispersants are basically polymer alkyl thiophosphonates and other kinds of organic materials. So these are also added into engine oil as well as in other kinds of lubricating oils. Other important additive is foam inhibitors. Because of the presence of various kinds of additives and especially the detergents and dispersant, the foam can form, and presence of foam will basically reduce the performance of the lubricant because foam has air bubbles inside. So the air will take space and therefore the presence of lubricating oil will be reduced on the metal surface. So therefore foam inhibitors are used. Silicon polymers and organic copolymers are added as foam inhibitors. One important thing is that if we add foam inhibitors more than the necessary, then it might have a reverse effect. That means it might make more foam. So therefore it is important that the amount of foam inhibitors must be just the optimum. Now these are the additives which are present in lubricating oil. What is important is with time these additives can get depleted because these additives are used up during the performance of engine or any kind of machine. So therefore at some point the additive package can be almost become completely depleted, and in that case it is necessary that we do the oil change. And that's the reason why cars or any kind of vehicles have to have oil change at regular interval, because the oil quality continues to go down. It is not just the viscosity, but all the additives are consumed during the process. So this is the main aspect of additives for lubricating oils. Other than these additives, there can also be emulsifiers or de-emulsifiers depending upon the application. So for example, cutting fluids may have emulsifiers so that oil and water mixture can be made to be used as a cutting fluid. So depending upon application, some more additives may be added, but these additives are the main additives for most of the lubricating oils. So we have seen that lubricating oil has got two components. One is the base oil and the second part is the additives. So additives have got many functions, and therefore there are many types of additives that are added to a lubricating oil. I will show you another kinds of lubricating oil, and this one is mineral oil based. Previously I showed you the synthetic oil based, and this one is mineral oil based. So in fact this is slightly much cheaper actually, and this one meets API SL requirements of valve train wear, recommended for 4-stroke bikes and scooters. And this oil looks something like this. So in terms of viscosity, it is very similar to the synthetic oil that we were talking about, but it has got some different types of additives, but most importantly this is with mineral oil as the base oil, and this is synthetic oil. Now one more thing I would like to show you is the oil after it has been used in an engine for about 5 months. So this is the same oil after 5 months of use. So you can see that this contains a lot of blackish things, and these are the degraded or oxidized different organic molecules. It contains soot from the engine, and it also contains some wear particle. But one thing we can see that this oil keeps all the wear particles and oxidation products in dispersion. So even if I keep it for a week without touching it, nothing settles down. Everything is in suspension. So that means the detergent and the dispersant is working very well. So this kind of additive will not make any deposit on the metal surface. Although this has a lot of degraded and oxidized materials, but still it can work because all the products of oxidation and wear particles are still suspended inside the liquid, inside the lubricating oil. And lastly, I would like to say that lubricating oils contain a lot of sulfur and phosphorus compounds, and therefore these oils are quite toxic for the environment, and the disposal is a big problem. So it is very important that we dispose these used oils carefully so that it does not destroy our land or our water, because these toxic materials can go into the water bodies, for example pond or river or sea, and can damage the aquatic animals, as well as if these oils go into the farm or in the land, then it will affect our agriculture. So the environmental sensitivity is very, very important, and that's why nowadays people are also talking about green lubricant. That means lubricant which does not have these damaging compounds like sulfates and phosphates. Thank you very much for your attention, and I hope you learned something about lubricants and additives. Thanks for watching this video.